So these are some of the mean or basic working principle of the capacitor, that when we are applying a pressure here in for this particular application, its capacitance is going to change, and how the capacitance is changing, that actually we people are interested to see in this one. So how the differential pressure sensors are used depending upon the capacity or delta cell type for the measurement of pressure in this particular point. So over here, the operation of the capacitive pressure transducer is depend upon C is equal to, now the formula has been somewhat changed, that is epsilon 0 epsilon r a divided by a. So here the change in the distance between two plates is inversely proportional to your capacitance, whereas A is the area in meter square. C is the capacitance of capacitor in terms of faraday. Epsilon 0 is nothing but it is epsilon 0 is nothing but it is 8.854 into 10 raised to 12 farad per meter square, and epsilon r is dielectric constant. So these values we people are having, depending on which we people can measure the change in the capacitance depending upon the variation. So the simple structure for the measurement of either pressure. But prior to that, if we try to understand the concept of capacitor, that will help us to understand the concept in the better manner. Okay, so over here, the capacitance of the capacitor that will try to change when we are going to change the area of the plate. Then it is possible to change the capacitance depending upon the distance between two plates, and the dielectric constant er, so epsilon r, it is epsilon r changes. So these are the parameters, that is nothing but area, distance, and epsilon r. And what is epsilon r? This is this particular term is this one. So dielectric constant. So C is the function of your alpha 1 by D. And this is nothing but this is the basic for the capacitor pressure transducer. So here we people are having two plates, and this one is the third one. Now here, if suppose these are the two plates, if if I consider this middle plate is either going to move to this side or either going to move to this side, then what is going to happen? There will be variation in the displacement of this particular type of capacitor. There will be variation in the particular type of capacitance, change in capacitance. What causes change in capacitance? The motion of this particular mean cause the change in the capacitance. Okay, so here actually we people will conclude of this particular lecture, but the change in the capacitance that we people are going to carry out depending upon the pressure one is totally depend upon the parameters that has been specified to you. How we are measuring utilizing the delta cell. So I would like to give you one structure diagram for this one is suppose I am having the structure, and here is the diaphragm like a structure. So this is nothing but this is the plate which we are having. How actually pressure is measured? As you people have seen that capacitance is nothing but it is the function of 1 by d, means it is inversely proportional, and whatever the plates which I have represented over here, there are three plates. There are three plates with us, and these particular three plates, they are having some particular distance. If I have considered this distance as this particular distance as a x, yes, so or rather than that, we can specify this one as, suppose this one These are the plates. What is happening over here? The entire distance is x. I have considered the entire distance as a x for this one. Now, this particular distance is this one I will represent as a y. This one as a y. And what is going to happen when this plate is going to move in the up somewhat this direction? So my y, suppose y plus 1, y plus 1, here I am getting. So this y plus 1, this is y, but this has been changed to y plus 1, and this particular one is nothing but x minus y plus 1. So for measurement of the variation in the distance is this particular expression, which is resulting in the change in capacitance. Now, how these changes are verified, or how these changes are reflected based upon the input pressure that has been applied to the deflection mean or to the capacitive type of transducer. So at the first point, we are supposed to understand the particular concept that here we are trying to measure the pressure, but the pressure is calibrated in terms of capacitance C. Now, the simple concept that can be incorporated, here is the path, and this is represented likewise. Here is the another mean for the measurement of pressure. How we people are executing that particular task is the important point for we people. Now, this one is our plate. And here actually we people are trying to delta C capacitive. I have not represented. Only a simple structure I am representing in front of you. That here I am applying a pressure, and across this one we are trying to measure the output in terms of electrical mean. That is nothing but my EG. So what is going to happen when I am applying a pressure P1 and here I am applying a pressure P2? So if suppose my pressure P1, now I will draw a simple figure for your better understanding for the capacitive mean in the proper manner. That structure is like this. Suppose this is the structure and here is the plate. So there are three plates we people are having. This one is nothing but this particular part is open. This one is the open one. I will represent it with the another color. This one is the open part. This one is the open part. This one is the open part. And this is going to be deflected one. This one is going to be a deflected one. Now we can consider the case. This is my P1. This is my P2. At the first case, if my P1 is equal to P2, what will be the change in the capacitance for case 1? When my P1 pressure is equal to P2, what will be the effect on this plate? There will be no change in the particular plate. So when there is no change in the plate, at that moment, the resultant output generated will be 0 for this particular capacitor. Now, the case second, we will consider that how many people are going to get P1 is greater than P2. Now, my P1 is suppose 10 psi. For your understanding, I am telling and is greater means it is 5 psi. This one is the 5 psi. That is my P2. So what is going to happen when P1 is greater means the pressure applied from this side is greater. This will lead the deflection to this side. This will lead the deflection to this particular side. So the resultant output will be generated for the case 2, or I will represent this one as a case 2. So here I am going to get, this is not going to be equal to 0. This is not going to be equal to 0. This will try to lead the movement of the plate as per the definition. If suppose distance in the plate varies, distance in the plate varies at that particular moment over here, at that particular moment over here, if suppose I am representing this one like this, so as to measure the electrical output. So this is the change in capacitance, because here what happened, I have got the change in the displacement of this particular plate. So my distance has been changed, and no doubt my capacitance is the function of the distance. So I am going to get some value of E0, some value of the E0. But this E0 is totally depend upon the change in capacitance. That is the voltage which I have got is totally depend upon the change in the capacitance. But what is the cause of change in the capacitance? The applied input pressure P1 and applied input pressure P2. Only the difference is that here my P1 is greater than P2. That's why the deflection of the plate is towards my P2. Suppose a small kid of 10 kg weight or studying in the second standard or fourth standard, and you people, whether both of you are trying to push each other, at that time what is going to happen? You can easily push the fellow who is in the fourth standard because he is unable to oppose you. So here also, as your pressure P1 is greater, then the deflection will be in the opposite direction, or the deflection will be towards. But this will result in the change in the distance between the two plates. Okay. The third case is that if suppose my P2 is less, P1 is less than my P2, is less than means P2 is greater than my P1. At this moment, what is going to happen? This is the structure of the plate. From here, I have taken the resultant output E0, and this is the plate. At that time, when I am applying a pressure from this side, no doubt the change in the deflection will be towards this side. So the deflection will be to this particular side, resulting in the output of E0. Okay. So this particular E0 will be the output that has been generated for the capacitance 1. For the capacitance 1. So this change in capacitance is calibrated in terms of